So, when you're deploying stateful apps in Kubernetes, the key thing to remember is that state needs to persist outside of the pod lifecycle. That's why we use stateful sits and persistent volumes.
Yeah, but what about when you need high availability?
Exactly. High availability means ensuring your data remains accessible even if a node fails. With stateful applications, you often have to think about distributed storage solutions like Ceph or Glusters to keep everything consistent across nodes.
But isn't it simpler just to stick with stateless services?
It can be simpler from an architecture standpoint because each instance is interchangeable, and you don't have to worry about maintaining state across different instances. However, that doesn't mean it's always easier in practice. Stateless apps still require careful management of external dependencies and service discovery.
I've seen some teams manage stateless deployments really well, though.
Sure, but managing those dependencies becomes crucial. You end up needing robust monitoring and alerting systems to catch any issues before they impact users. And let me tell you, debugging a misbehaving stateless app can feel like searching for a needle in a haystack sometimes.
What's the most common mistake people make with stateful apps?
Often, they underestimate the complexity involved in keeping state consistent across multiple replicas. People forget that consistency and partition tolerance are trade-offs according to CAP theorem. Also, handling updates without disrupting existing states requires meticulous planning.
Like rolling out database schema changes?
Precisely. You need strategies like blue-green deployments or canary releases to minimize downtime and risk. Plus, testing these scenarios thoroughly is essential, but frequently overlooked until something goes wrong live. Speaking of updating stateful applications, rolling updates and rollbacks in Kubernetes are critical to manage disruptions. Have you had much experience with that?
A bit, but I'm always looking for ways to improve.
Absolutely. For rolling updates, you want to configure the maximum available and max surge of parameters carefully. This ensures that not all pods go down at once and keeps enough replicas running to maintain service availability.
Makes sense, especially when dealing with high traffic.
Definitely. And when things do go south, knowing how to roll back quickly is crucial. Setting up automated rollbacks based on health checks can save a lot of headaches. You just need to ensure your deployment strategy includes a way to revert changes if the new version causes issues.
How do you handle rollbacks without causing downtime?
Well, it depends on whether your application supports multiple versions running concurrently. If so, you can gradually scale down the old version while scaling up the new one, and if needed, reverse the process smoothly. It's also helpful to have detailed logs and monitoring set up so you can pinpoint exactly what went wrong during an update.
That sounds like a robust approach.
It is, but it requires thorough testing beforehand. The last thing you want is a rollback scenario that takes longer than expected due to unforeseen complications. Always have a fallback plan ready and test it extensively in staging environments first. Speaking of robust approaches, have you ever used the blue-green deployment strategy in Kubernetes? It's quite effective for minimizing downtime and reducing risks.
I've heard about it, but haven't implemented it yet. How does it work exactly?
Essentially, you run two identical production environments side by side. One is the blue environment, and the other is the green. You deploy new changes to the green environment first, test them thoroughly, and then switch all traffic over to the green environment. This way, if anything goes wrong, you can immediately switch back to the blue environment.
That sounds like a safer way to handle updates.
Absolutely. It allows you to validate your new deployment without affecting users. Plus, rolling back is as simple as switching traffic back to the previous stable environment. You can even automate this process with tools like Helm or custom scripts.
Automating it would definitely save time and reduce errors.
Exactly. Another benefit is that you can perform zero downtime deployments since both environments are running simultaneously. Just remember to balance the load properly and ensure that session data is handled correctly when switching between environments.
Handling sessions must be tricky.
It can be, especially with stateful applications. You need to make sure that any session data or user-specific information is either replicated or managed externally so that users don't lose their context during the switch. Using shared storage solutions or external session managers can help here. Another effective strategy for risk mitigation is using canary releases. Have you explored that in Kubernetes?
I've read about it, but I haven't tried it yet. How does it work in practice?
With canary releases, you deploy a new version of your application to a small subset of users or traffic. This allows you to test the new version in a real-world environment without impacting everyone. If everything looks good, you gradually increase the percentage of traffic directed to the new version.
That sounds like a controlled way to roll out updates.
It is. You can use Kubernetes deployments and services with weighted round-robin routing to manage this. For example, you could initially direct only 5% of traffic to the canary release and monitor its performance closely.
Monitoring would be key then.
Absolutely. You need comprehensive monitoring and logging to detect any issues early. Tools like Prometheus and Grafana can help you track metrics and set up alerts for anomalies. Additionally, having clear criteria for scaling up the canary release or rolling back if problems arise is crucial.
Clear criteria would indeed make the process smoother.
Definitely. You might also want to consider using Istio or another service mesh for more granular control over traffic routing and observability features. This way you can fine-tune how much traffic reaches the canary release and easily switch back if necessary.